Embedded Trust. Embedded Trust is the newest addition to IR Systems product offering. Embedded Trust mainly covers five core security domains. So we cover security development environment, integrated identity and certificate management, secure boot manager, secure deployment with integrated manufacturing mastering, release management with versioning and update infrastructure. So this solution integrates really smoothly in your workflow. So how does it work? So we have some ready projects here available, and also the secure boot manager that can be customized. I can show that in a separate video. So we have a few ready examples here. So if I just select here a destination folder, I'm copying the demo project here, and as you will see, it will mainly create a workspace that includes the secure boot manager and also our demo application. So the secure boot manager, if you want to have it customized or create it again, we have a template here, so you can create a secure boot manager again from the scratch. But I have it ready here, and for us what's important actually is that the right device it's selected. In this case we have STM32H753, and of course we need to have the security here enabled with a profile. We already have a profile selected here, but we can create a new one. So I will show you how that works. I will create a new one. I will use this easy template, not the advanced one. And we are using here the certificate builder. Once I start this process here, I need to define a name. Let's just call it STM or ST2. I can mainly select here what I would like to have as output folder. And this is really straightforward. We only need to select here the output directory and the provisioning folder, and finally you of course need to define OEM name, and from here we can launch the certificate builder. So this is how the certificate builder looks, and you can of course create all the keys and do the step-by-step either with a basic root, intermediate, or even end certificate here. You can use templates, but I will use the full chain. What I'm looking here is to have the complete chain of trust, and the way it works, I will just start here with the templates, and I need to create keys here. Same is valid for here. Probably should use a different one here. So we have three different keys with easy root, easy intermediate, and easy device template. And once I create here, we see the chain of trust available here with the root certificate, intermediate one, and end certificate. The only thing I need to do here is actually to save this to XML file. I have this destination folder that I defined before. I will do a default save all. This is how it will look. So it has actually saved the XML. From here I can switch back to the ID and confirm. And from here we expect actually to have our new profile also available here. So we have the ST2 engineering profile available. I'm selecting that one, and we have the option here to either read the device hero ID from the device or have a fixed value. We of course use the better one, so we read out and we make it unique. It's very important that I notice here exactly what I'm using, because the same profile needs to be used later in the application. So I can confirm here. I will confirm here, and I will mainly build this application. It's up to date, and from now I can actually do what I mentioned before, that it's the provisioning. So we will read out the device ID, and this is the way it works. So we are reading out the device ID, and we have the ambition to create the end certificates with this information. So if we have a look here on the debug log, we can see that we were reading the device, we found it, and this information, actually if I expand it, you will see that the new certificates here have been created with that information. So from here, what I need to do, I need to program the Secure Boot Manager to the target. So that's actually what I'm doing here now. So once the target is programmed, I can switch to my application. And as I mentioned before, I need to make sure that I'm using exactly the same profile. So what I can do, I can either import an existing profile, or I can use the new one that I just defined. So I'm using the same profile as before, version 1, and from here I can confirm it. I just need to make sure that this application is up to date, so I need to make a build here quickly. So the project should be up to date, and I can also just force the mastering, so it will add version 1 into this application. And from here I can of course connect to the target by programming the application, but the way it works is that it's being placed in a separate area in the memory or even external memory, and from here the Secure Boot Manager starts. It's doing all the decryption and placing actually this application in the right place. So if we have a look here on what happened on our boot, we can see that it actually installed version 1. So we have everything up and running on this easy way to make use of the application. So what I also want to show you, start specific places. This was the last one that has been generated. So what I want to do now here is actually to use the certificate builder to have a look what we have right now here in this case. I selected the folder. I can even check the hierarchy, the self-signed certificate, that's the root. And if we look here on the end certificate, we will also notice that the certificate serial number actually matches with the device ID. So here we have the complete flow, and like mentioned before, the IR solution with Embedded Trust, it covers security development environment, integrated identity and certificate management, Secure Boot Manager, secure deployment with integrated manufacturing, mastering, release management with versioning, and update infrastructure. So I hope you liked this video, and just let us know if you have any questions.